All right, so in this video, we're going to look at how to find confidence intervals for the slope of the regression line in the TI-84. Now, we're going to begin by entering our regression data into the lists. So list 1 will be the X values, and L2 will be the Y values for our example. Now, the lists don't need to be ordered per se, but the corresponding values do need to correspond with each other. So once you've entered them into the list in the order provided, don't like sort the lists or do anything like that to them, because that will mess up the ordering, the relationships between the two columns. Again, I have another video on how to enter data into the list if you don't know how to do that. But we're going to enter the data into the lists, essentially select stat, then edit, and then if the lists are empty, you can just enter the data right away. You may need to clear the list, scroll up, and hit clear. Do not hit delete, hit clear. Okay, so once the data is entered into list 1 and list 2, then we can go ahead and we can do our calculations. So quit out of this screen, so second and then the mode key to get back to the main screen, and then we're ready to calculate. Now, to calculate our t-interval for the slope, we're going to use, under the test menu, the Lin regression t-interval. So select stat, and then scroll over to the test submenu, and then scroll down almost to the very end of the list. It may be faster to scroll up. We're going to use Command G, linear regression t-interval. Now, from here, a lot of this is going to look very normal to things that we have done for other kinds of hypothesis testing or for other kinds of calculations we've done. It's going to ask for the X list and the Y list. So we're going to specify list 1 for the X, list 2 for the Y. If you've used other lists for this, then you do, of course, need to specify which list you use for X and which list you use for Y. List 1 can be typed using second 1, and list 2, second 2. The frequency should be set at 1 because most of these problems do not have frequency lists to go with them. And then the confidence level we're looking for our interval, typically it's a 95% confidence interval, but your individual problem may have other confidence levels in mind. Again, enter this as a decimal. You can have the regression equation stored someplace. If you want to do that, then you can specify Y1, for instance, to save the equation that is calculated. This is another way to get the regression equation from out of the calculator instead of from the linear regression calculation that's in the other menu. But if you wanted to enter a function here, you would go to the vars menu, then scroll over to yvars, and then hit function, and then select the Y1, Y2, whatever function that you wanted to store it in for the regression equation. But this is optional. And then finally, you would select calculate. Now, when the output displays on the screen, then you're going to get a lot of information, including the values for your regression equation, such as the values for the intercept here. Well, in fact, in this case, the slope is the 1.4, and the A is the intercept down here. Your R and R squared values should appear down here, assuming your diagnostics are turned on. The confidence interval for your slope is here. So notice that the B value from the slope value, and again, you can the system will remind you of what the B stands for by specifying the regression equation here. You can see that this B value does fall inside this confidence interval. So that is the confidence interval for the slope. And then they give you a whole bunch of other information like the degrees of freedom and the standard error, and again, the intercept. And again, down at the bottom, if you keep scrolling, these correlation values and the R squared value, the coefficient of determination. Now, what can we use this information for? Well, we can use it to calculate sort of the bounds of our regression line. And so what I've done with this example is the center line is the regression line that was calculated from our results. But then I went and I adjusted the slope drew two additional lines. The bottom one is the slope from the bottom end of the confidence interval, and the top one is the slope from the top end of the confidence interval. And so again, this is just a way of visualizing this idea that given the data we have and the sample size available, we estimate, our best estimate for the slope is the center line, but because it's a sample, there's enough variability that it's possible that the slope is as small as this or as large as this one. So again, that gives us bounds on our regression line. How sure are we about the confidence? How sure are we about the value of our slope? And if we're not 100% sure, what are the likely bounds? Again, 95% confidence bounds on that slope coefficient.